I'm Destiny Thomas. I'm a museum astronomer, and we're here at the Cleveland Museum of Natural History. An astronomer is a scientist who studies outer space and everything beyond the Earth's atmosphere. For me, I got interested in astronomy going to local planetariums as an elementary school student. So going into that planetarium and seeing all those beautiful stars above me made me really interested in learning what's out there with astronomy. An eclipse is an occurrence where one celestial body is blocked or obscured by another celestial body. We have solar eclipses and lunar eclipses. A solar eclipse is where the Earth falls within the shadow of the moon, and then a lunar eclipse is where the moon falls within the shadow of the Earth. So we have about 2 to 5 eclipses every year, and they're divided between 2 seasons. We have 2 eclipse seasons per year. Within each season, we have at least 1 solar eclipse and 1 lunar eclipse. Eclipses are predicted by studying cycles, and so this is going to include the moon's orbit around Earth and also the Earth's orbit around the sun. Now, we've been able to predict eclipses very accurately since the 1700s. We can predict them up to multiple centuries in advance. Once we get to about 1,000 years out, it gets a little less accurate because the Earth's rotational motion is actually changing over time. The Earth is slowing down, and the moon is also getting farther away from the Earth. So every year, the moon gets about 1.5 inches farther away. In about 600 million years, we'll no longer be able to have a total solar eclipse. On April 8th of this year, we're going to have a total solar eclipse, and when the moon shadow is going to cross the United States, it's going to start in Texas, going through about 13 states all the way up to the state of Maine. So when we're talking about total solar eclipses, we want to focus on the path of totality. That's where the darkest part of the moon shadow will cross the Earth, and if you are within the path of totality, you get 100% coverage of the sun at some point during the day. For us here in Cleveland, we're less than 25 miles from the central line, which means the closer you are to the central line, the longer duration of totality you have. We have one of the longest durations in the state. We'll have 3 minutes and 50 seconds of totality in Cleveland. Everyone else in the United States, if they're outside of the path of totality, will experience a partial solar eclipse. On April 8th, the entire eclipse is going to last for about 2.5 hours. For us here in Cleveland, the time of first contact, the very start of the eclipse, will be 1:59 in the afternoon. And then we get to totality at 3:13. We hit the maximum of totality at 3:15. It ends at 3:17, and then the very end of the last partial stage will be at about 4:30. So if we're in Northeast Ohio, for us to observe the total solar eclipse, you want to look towards the southwest. And then the sun and moon, they'll be about 50 degrees above the horizon. A technique that you can use is to actually extend your arm out in front of you, and you want to make a fist with your hand. You'll start your fist at the horizon, and then if you go up about 5 of your fists high, that should be about 50 degrees up. That gives you a good estimate to have an expectation of where the sun and moon will be for the total solar eclipse. It's very important to protect your eyes during the total solar eclipse. The only time you can look up at the sun with your unaided eye is during totality. Outside of totality, before and after, you want to protect your vision because the sun's so bright. So you can have permanent damage done to your eyes. You can also have retinal damage because the sun's light is so intense. So make sure you have safety precautions in place. There's going to be so much to see when you're looking up in the sky for the total solar eclipse. There's also going to be a lot to see if you look around you in your environment. So as the sun is being eclipsed by the moon, you might start to see how shadows are changing. As we approach totality, shadows may appear to be sharper. And also, you'll be able to see those partial phases as they're projected onto different surfaces. It'll almost look like a solar crescent projected on the ground. For all my students out there who are really excited about astronomy, a big piece of advice that I have is to explore the sky. So if you have a telescope, you can look up at the sky during the night. If you want to do any solar viewing, make sure you have proper solar filters to do that during the day. And also just stay curious. Stay curious about all the things that you can learn because there's so much out there in the universe.